Let's take a look at, if we remember, we graphed the sine of theta. We basically look at a unit circle. We're basing things off 0 degrees, where this is the point over 1 up none. The second point is your sine value. The first point's your cosine. So at 0 degrees, we're at 0. That's how I always recognize a sine graph. It's crossing through the origin. A cosine will never cross through there. Okay? Cosine will always be crossing through at a different location. Usually at 1 if we're doing just the cosine of theta. But we're going to learn today how to sort of stretch these waves. So our normal graph, pi is pi over 2 right here, if we remember, goes over 0 up 1. So when you're at pi over 2, you're here, and then you're here, and then here, and here. And it would be here, 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 and here. That's what our graph would look like. Looks pretty good, okay? That's our sine graph. Cosine would be same idea, but it would actually start here at 1 and have the same type wave. What I want to look at is what happens if I put a 2 out front, if I do 2 sine of theta or 2 cosine. Well, what we can do, and I'm just going to give a little quick explanation. If we look at what happens when, let's say, theta's value is 0 degrees and 90 and 180 and 270. Now, normally, here's what we're doing. We're doing 2 times that value, right? So what happens when we have 2 times the sine of theta? At 0, the sine is 0, so 2 times 0, still at 0, right? Let's do this in red. So we're at 0. But when we're at 90 degrees, it's 1. What's 2 times 1? 2. This guy moves from a height of 1 to a height of 2. Here we'll be at 0. If we look at 3 pi over 2 right here, which is over what? 0 down -1. Sine value is -1, so when I do 2 times that, it's going to shift it down here. What we notice is if we put a number out front, it elongates this. It's called the amplitude. Okay, you're used to that when you turn your music and it starts making those waves and you turn it up and boom, 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 it goes up real high. Okay, then you turn up the amplitude. So the wave is going up higher. So if I'd put a 3 out here, guess what? It would go up to a height of 3. If I put a 4, it goes to a height of 4. Okay, so that's what's happening. Now, so that increases it up and down, right? When you put a number out front. But what if I do a 2 right here? Instead of out front, I put it right here. This out front is called your A value, and this is going to be your B value. Well, what happens here, our normal wave, do a normal sine wave, that was terrible, but close enough, is there. What happens is this is a normal cycle, 360 degrees, right? It repeats after 360 degrees. That cycle repeats. It starts going again and again. This is going to break it into 2 cycles. Between 0 and 360, there's going to be 2 of them. So what's going to happen is it's going to shorten it up. And it's going to repeat once, twice. That's what happens. It compresses it. Think of like an accordion where we push it in, the music, and they push it in the accordion. It's just like that. If I put a 3, it's going to shrink even more. It's going to repeat itself 3 times between 0 and 360. That's what's going to end up happening. Now, what we want to be able to do here, what I have in blue is your typical sine graph. This would be, oh, wait, nothing changed. It's still just 1 cycle between 0 and 360. So all I did, though, but notice the height went up. This was obviously 2 times the sine of theta. Well, what about this guy? Well, the height didn't change. We didn't mess with the amplitude, but notice how the blue line is your typical sine wave. Boom, there's 1 cycle. But this one, as I said, 1 cycle, 2 cycles. So this was the sine of 2 theta. We want to be able to look at graphs and recognize them. Now, you will notice that I'm only concentrating sort of on the positive side. I'm not going to really concentrate on the negative side. negative meaning over here. So I sort of blocked this out. So if somebody said to me, what is the graph here, Mr. Hickam? Well, I would say, okay, it's y equals. We know that. Now, the first thing I have to think, is it sine or cosine? I don't know if this is a cosine graph or a sine graph. Well, I do, because it goes right through that origin. And the sine is the only one that goes right through that origin. Cosine won't go through there. So we know it's a sine. We know that. Now what I need to concentrate on is the number out front, the amplitude. Well, how high up does it go? It goes up to a height of 2. So I know there's a 2 there. And then I have to think, how many cycles between 0 right here to right here occur? Well, let's see. Down, up, boom. There's 1 cycle. Boom, boom, boom. 2 cycles. Okay, and it's starting to repeat itself. Boom, boom, 3. It repeats itself 3 times. So this is a 3 theta. And that's how I do it. I just count those cycles. It's been pushed in. All right, let's look at this guy. It's a y equals. Is it sine or cosine? Doesn't go through the origin. That means it's got to be cosine. Number out front is my amplitude. It went up to a height of 4. So boom, there's a 4 out front. Now, how many cycles just between this 0 to 2 pi occur? Well, it starts up top, goes down, comes back, starts up top. Okay, it's getting ready to start over again. So there's 1 cycle. Boom, 2 cycles. So it's 2 theta. That's what we're doing. The number out front is the amplitude. That does height up and down. And the number right here is telling you how many times between 0 and 360 the cycle repeats itself. Okay, and that's your B value. That makes it sort of stretched in or stretched out, which we'll look at in some example problems if you come to class today.